Okay, so we got this crazy looking limit here, the limit as x approaches 0 of x times e to the x plus 1 divided by x times pi to the x plus 1, all being raised by having the power of 1 divided by x squared. It's kind of crazy looking, probably complicated from first sight, but computing this is going to come out very nice. So that's actually today's video. We're going to be computing this limit here. So first thing I want to do is I want to define y to be this function here. Y is equal to x times e to the x plus 1 divided by x times pi to the x plus 1, all being raised by 1 over x squared. Okay? And our next step I want to do is I actually want to take the natural log of both sides. So we have ln of y, which is equal to, we take the natural log, so we move our exponent to the front, which is just 1 over x squared. And then using our natural log rules, we have the ln, I'm going to put a bracket here, so the ln of x times e to the x plus 1. And then it's under division, so we actually subtract, so minus ln of x times pi to the x plus 1. And then if we want to, I can actually just rewrite this as the natural log of this. I'm simply just multiplying the 1 over x squared. I'm just distributing to these terms here. Plus 1 divided by x squared, and then minus the natural log of x pi to the x plus 1 divided by x squared. Okay. Now before we continue further, I would like to address that we're taking the limit of this, but this is also mean we're taking the limit to we're taking the limit of this function here, but also taking the limit of y. So one thing I want to say is that the limit as x approaches 0 of y, what we could do is we can actually rewrite this. It's the same way as saying the limit as x approaches 0 of e raised to the ln of y. And in other words, it can also, because we have an e base, the only thing we're actually taking the limit to is just the ln of y. So this is the same thing as e raised to the limit as x approaches 0 of ln of y. So basically what we're doing is we're actually taking the limit of this function in particular. So now that we have that established, okay, the next step that I want to do is I want to rewrite the expressions for both these terms, so that way there's actually a multiplicative inverse involved. So what I'm saying is that I want this term, let's pay attention to this term for now. I want there to be a x times e to the x divided by x times e to the x, which is equal to 1, and that defines the multiplicative inverse. Same thing for this one, but except it'd be x times pi to the x divided by x times pi to the x again. So that's what I'm gonna do. So when we rewrite this, we have the limit as x approaches 0 in the brackets. So we have x e to the x divided by x squared multiplied by the natural log of x to the e to the x plus 1 divided by x to the x times e to the x, then minus x times pi to the x divided by x squared, then times the natural log of x times pi to the x plus 1 divided by x times pi to the x. And now I'm going to be using the fact, so note that the limit as x approaches 0 of the natural log of 1 plus x divided by x is equal to 1. So the way to do this is you just plug 0 into here and you get a 0 over 0 indeterminate form, meaning you can actually take L'Hopital's rule. So you take the derivative of the numerator and then take the derivative of the denominator. So simply this is just ln of 1 over x up for the top and then just 1 on the bottom. And if you plug 0 from there, you get that it's equal to 1. We're going to be using this to we're going to be using this fact to compute these limits here. Basically, the same thing can be said. So we're replacing x with x times e to the x, and then the numerator is also x times e to the x. So that means this limit here is equal to 1. The same thing for here, x times pi to the x. We replace it for x. We replace it from x, I meant to say. And this is also equal to 1. And you can actually take L'Hopital's rule for these two terms, and you get that they're both equal to 1. So L'Hopital's rule over here. So let me write this way. By L'Hopital's rule. Then we can rewrite this as let me draw an arrow over here. We rewrite this as the limit as x approaches 0 of the x's cancel out here, so this is just e to the x divided by x, and then multiply by 1. So I'm just gonna multiply by 1, then minus x's cancel out, so it's just pi to the x divided by x times 1. In other words, it's the same thing as the limit as x approaches 0 of e to the x divided by x. Let me actually, since they have a common denominator, I'm going to write it this way. I'm going to write e to the x, then minus pi to the x, then divided by x. Okay. And now, next thing, we could just take the limit. So it turns out when we plug 0 for x, so e to the x is, or e to the 0 is just 1, pi to the 0 power, it's 1. 1 minus 1, 0, x, that's 0. So this is a 0 over 0 determinant form. So we can use L'Hopital's rule to take the derivative of the top and the bottom. So again, by L'Hopital's rule, just draw an arrow over here. Then the limit as x approaches 0. And I'm also going to write it this way. So this is taking the limit of x approaches 0 of the numerator. So this is just e to the x, then minus the derivative of pi to the x is just pi to the x, then times the natural log of pi, and then the limit as x approaches 0, its derivative of this is just 1, so this is just the limit as x approaches 0 of e to the x minus pi to the x ln of pi. And then when you evaluate this at x equals 0, this is simply just equal to e to the 0, which is 1, and then minus pi to the 0, which is 1, then multiply by ln of pi, so it's 1. So 1 minus ln of pi. And that's actually equal to our the limit as x approaches 0 of the natural log of y is equal to this. Where x is ln of y. Okay, so now that we have this, so now going back, we have that e raised to the limit as x approaches 0 of ln of y. We just established that this is equal to 1 minus the natural log of pi. So this means it's just e raised to the, let me actually rewrite this, ln of y equal to e to the 1 minus ln of pi, which that's the same thing as, we can separate the bases, it's just e to the 1 multiplied by e to the negative ln of pi. This is just move the negative as an exponent, so pi raised to the negative 1, e to the ln, they cancel, so this is simply just e to the e over pi, like so. Pretty cool, right? It is.